Now the topic is signal conditioning circuit. The signal conditioning circuit. First, before to start this topic, we have to know what is the need of the signal conditioning circuit. What is the need means why we have to use the signal conditioning circuit, because the sensor that it give or the transmitter giving an output corresponding to your physical quantity. Why you have to conditioning that signal? That is the need of the signal conditioning circuit. Usually the output from the transducer or sensors are not sufficient to drive the display or recorders. The output from the sensor or transducer are in very low voltage or low, that it gives only a low current. Therefore we have to amplify, and then that magnitude and all very small, that it is combined with the noise. So we have to conditioning the signal or reconditioning or to filter out or to remove from noise. That is called the signal conditioning of the circuit or signal conditioning. Therefore it is necessary to amplify, and conditioning of the signal is essential. Some of the signal conditioning circuits are follows: 1. Op-amp, integrator, differentiator, instrumentation amplifier, etc. The signal conditioning circuit has to perform the following linear process. They are: 1. Amplification, attenuation, integration, differentiation, addition or subtraction. These are all linear process performed by the signal conditioning. Apart from that, we are also having a non-linear process. Some of the non-linear process is also included in the signal conditioning circuit. They are: 1. Modulation, demodulation, sampling, filtering, clipping, clamping, squaring, linearization or multiplication by another function. Okay, generally the transducer are two types. One is a passive and active. Already we know that there are two types of transducer. One is a passive and active. What is a active transducer? What is a passive transducer? The external source or excitation is required for passive transducer. Example: strain gauge, potentiometer, capacitive transducer. But the active transducer does not require the external excitation. Example: piezoelectric crystal, inductive pickup. Therefore the active transducer produce their own voltage only by the application of physical quantity. What is the meaning? The active transducer, that it has to generate their own output voltage corresponding to the physical quantity. Usually in general that it is very lower in value or lower in magnitude. Thus the signal are at a low level required amplification. There are two signal conditioning system. One is a DC signal conditioning system, another one is AC signal conditioning system. We can see first DC signal conditioning system. The DC signal conditioning system, the transducer consists of one of the arm of the bridge. Already we know that bridge is consisting of 4 arms: 1, 2, 3, 4. Okay, here we have to give a input, this one is output. Okay, so the bridge is excited by DC source. Balanced condition is achieved by a potentiometer. So how the balanced condition is achieved? One of the resistor is variable. So we have, if you vary that, the potential by using a potentiometer, the resistance get varied. Therefore the balanced condition is achieved in the bridge. The DC amplifier should have the following characteristics. 1. Differential amplifier must have a high CMRR, common mode rejection ratio. Okay, you studied in your linear integrated circuit. Okay, it should have a good thermal and a long term stability. Stability is strong or good. Easy to calibrate at lower frequency. Okay, this is the block diagram for a DC signal conditioning. Measured value to be quantity to be measured or measurement, transducer, bridge, DC excitation, calibration, zero in network, power supply, DC amplifier, low pass filter output. Okay, disadvantage. The main disadvantage of the DC signal conditioning is drift. What is the meaning of drift? Drift is called simply it is a deviation from the particular value, that is called a drift. Then AC signal conditioning system. The block diagram of AC signal conditioning system is shown here. Measurement, transducer, bridge, calibration, zero networking, AC amplifier, power supply, carrier oscillator or a carrier frequency, phase sensor detector, low pass filter output. AC signal conditioning system is shown in figure. Okay. In general, the transducer are variable resistance or inductance type. The signal frequency are imposed over a carrier frequency of 50 kHz and 200 kHz. These carrier signals are usually 5 to 10 times greater than the signal frequency. The output of transducer is applied to the bridge circuit. Then this output is modulated by carrier signal. Then this modulated output is applied to the phase sensitive demodulator. Demodulator means removing the carrier signal from the signal. Okay, this process the DC output that indicates the direction of the parameter change in the bridge output. It avoids the drift problem. But here it is very difficult to obtain a stable carrier oscillator. What is a stable carrier oscillator means? The oscillator must have a same frequency, that it has to be maintained at any instant, so that it is very difficult. Okay, but here it is very difficult to obtain a stable carrier frequency. Thus active filters are used to reject this frequency and prevent the overloading of the AC amplifier, or we have to use a crystal oscillator to get a stable carrier oscillator. The phase sensitive detector is to filter out the carrier frequency component of the data signal. Okay, then one of the circuit which is used in AC amplification is an amplifier. Block diagram of a op amp. This is your input stage, instrumentation stage, level shifter, output stage, output. Here we are having a 2 input, here we are having a single input. Okay, this is the input stage, intermediate stage, level shifter, output stage. Okay, the amplifier basically consisting of 4 stages, 1 2 3 4. Its block diagram is shown in figure. The first stage is a double-ended high gain differential amplifier. This one is a high gain amplifier. It provides a high voltage gain. It is a dual input. This is a dual input balanced output differential amplifier with a constant current source to increase the common mode rejection ratio. The second stage is intermediate stage. It is a single-ended differential amplifier. This one having a double output. This one having a single output. The second stage is intermediate stage. It is a single-ended differential amplifier. The third stage is also a level shifter. It's also an emitter follower circuit. It's also having a single-ended. Its output is a DC. The output stage or a final stage is a push-pull complement. This one output stage is a push-pull complementary amplifier. Okay, that's all.